Hello everyone and welcome. Today we are tackling variation in math. Direct, inverse, joint, and combine. By the end of this video, you'll understand what they are and how to solve them. Direct variation, as one variable increases, the other increases proportionally. The formula is y equals kx, wherein y and x are variables or things that can change, and k is the constant of variation, that is a fixed number that tells us how y and x are related. Example, the more apples you buy, the higher the cost. If one apple costs $2, k equals 2, then y, the total cost, is equals to 2x, number of apples. Next, we have another example. If y equals to 8, when x equals to 2, what is y when x is equals to 7? First, find k. The formula that we will use is k equals y over x. We'll need to substitute y and x, which is k equals 8 over 2. After that, we'll divide 8 and 2. If you divide that, we will get 4. So the constant of this variation is 4. So when we write it again, it will be y equals 4x. So now let's find y when x equals to 7. First, substitute the x, which is 7. After that, multiply 4 and 7, and you will get 28. That's the y when x is 7. Remember, direct variation is all about constant relationship between two variables. As one increases, the other also increases proportionally. Second, inverse variation. As one quantity increases, the other decreases proportionally. Their product is always constant. xy equals k. Also, graphically, since the two variables are inversely proportional, the graph is a unique curve called hyperbola. In these examples, it shows here the relationship between speed and time over a fixed distance. The faster you drive, the less time it takes. Let's take a look at the table. This shows that when the speed is 30, the time is 20. So when the speed increases to 40, the time drops at 15. This shows that our first example is an inverse relationship. First, let's find our constant, k. We multiply any pair. Let's use 40 and 15. K is equals to 40 multiplied by 15. Multiplied 40 and 15, and you will get 600. So that's mean our constant is 600. That's the total distance traveled in units, like miles or kilometers. This is the constant proves that the relationship is inverse. If you use 30 and 20, you will get the same. The constant is always 600. When we double the workers from 15 to 30, the days required are cut into half. Let's try another example. Our second example shows the construction workers and the needed days to finish a house. When we double the workers from 15 to 30, the days required are cut into half, from 60 to 30. Like the first example earlier, we calculated the constant, then we multiply the workers by days. As you can see, the constant is 900, which represents the total amount of work. This is the total effort required to complete the entire house. Remember, the product of two variables is constant. Always calculate k first. The more you see it in different scenarios, the easier it will become. Joint variation. A quantity varies directly as two or more quantities. The formula is z equals kxy. First, let's find k, or the constant. We are given that z equals to 15 when x is equals to 3 and y is equals to 5. The equation is z equals k multiplied by x multiplied by y. Substitute the values. 15 equals k multiplied by 3 multiplied by 5. Simplify, it will be 15 is equals to 15k. Now let's solve for k. K is equals to 15 over 15. That will be 1. So our constant is 1. And now let's solve for z. Now we know k is 1 and we're given x is equals to 6 and y is equals to 2. Use the equation z equals to k x y. Substitute the values. Z equals to 1 multiplied by 6 multiplied by 2 and it will become z is equals to 12. Therefore, when x is 6 and y is 2, z is equals to 12. Remember, joint variation is a type of direct variation involving multiple variables. The area of triangle varying jointly with its base and heights is a clear example illustrating how changes in either variables directly affects the area. And lastly, combined variation. Combined variation mixes direct, inverse, and joint variation. And now, let's solve! Combined variation mixes direct, inverse, and joint variation. In this scenario, a variable varies directly with some variables and inversely with others, assuming the remaining variables are constant. Formula for combined variation: z equals kx over y, where z is the dependent variable, x is a variable that z varies directly with, y is a variable that z varies inversely with, k is a constant of variation. Example, z varies directly as x and inversely as y. If z is equals to 6, when x is equals to 3, and y is equals to 5, find z when x is equals to 6 and y is equals to 10. Equation: z equals kx over y. First, let's find k. 6 equals k multiplied by 3 over 5. Let's first multiply both sides by 5, which is 30 equals k and 3. Then divide both sides by 3, and that will be k equals 10. Solve for z with new values. Now that we know k is equals to 10, and we want to find z when x is 6 and y is 10, plug these values into the equation. Z is equals to 10 multiplied by 6 over 10, and then simplify. Z is equals to 60 over 10. Therefore, z is equals to 6. So when x is 6 and y is 10, z is 6. Remember that combined variation is when variables depends on multiple others through both direct and inverse relationship. Identify this relationship carefully. Set the equation with the constant k. Solve for k first. Maintain consistent units, and always check if your final answer makes logical sense. In summary, direct variation indicates relationship between two variables that are proportional. Inverse variation indicates relationship between two variables that are reciprocal. Joint variation indicates direct variation among multiple variation, and combined variation is a specific case of direct and inverse variation with relationships. And that's it. We've tackled direct, inverse, joint, and combined variation. Remember to identify relationship, find K, and practice. Thanks for watching.